Okay, so we're going to start our first unit and our first topic on combining functions. So a lot of this lesson we'll be looking at some background information. To start with, let's look at domain and range. So there's two different ways that you can express domain and range. You can express domain and range using interval notation, okay, such as the examples here, or you can express domain and range using set notation. Okay, so on your questions, you'll see multiple choice questions, numeric response with both different ways to represent domain and range. However, when you write your own domain and range, you can use either one. I'll never give you a question that specifically asks for one or the other. So to start with, let's talk about the difference between the closed and the open bracket. So if I had a domain, and we're going to write our domain in set notation, and I said x is greater than or equal to 3 or less than or equal to 5, where x is an element of any real number. And if I wanted to write that as an interval notation, it would look like this. So the square bracket represents a closed bracket. So that means it includes the 3 and the 5. If I had a domain written like this, where x was greater than 3 but did not include 3, and less than 5 but did not include 5, okay, then I would use a rounded bracket. When you're working with negative infinity and positive infinity, you'll always use the rounded bracket. The reason being is that you can't close in infinity. That's the way I like to think of it. All right, so the best way to look at this is look at a few examples. So it says state the domain and range in interval notation. So with domain, just as a kind of review, we're always looking at our x-axis. So the furthest I go to the left is -3. However, notice that's an open dot, so it does not include -3. The furthest I go to the right is +1. So when I write my domain, if I wanted to write it in set notation, I would say that x is greater than -3, but less than or equal to +1, where x is an element of all real numbers. If I wanted to write this domain in interval notation, then I would say use an open bracket, because it doesn't include -3, and a closed bracket at 1. So these mean the same thing. For range, okay, and just so you get in the habit, if you're choosing to write in set notation, the diploma or when I mark, I will be looking for that element of all real numbers. So for my range, if I wanted to write in set notation, now I'm going to look at the y-axis. So the furthest this graph goes up is at 0. The furthest it goes down is -4. So for all y values, I would say the lowest number is -4. And it is a colored in dot, so that means it does include -4. So I say y is greater than or equal to -4. Now y is less than or equal to 0. Sometimes I have kids say, well, the dot's not colored in here. Yeah, but it does touch the x-axis here. It does touch it where y equals 0, so that means if it touches, it includes 0. So y then is greater than -4 and less than or equal to 0. If I wanted to write this in interval notation, it would look like this. Okay, so both answers are acceptable. All right, I'll try these questions really quickly as well. So let's start with our domain. So I'm looking on the x-axis. So the furthest my graph goes to the left is -3. So I would say for all x values, x is greater than or equal to -3. And the furthest it goes to the right is 1, but it doesn't include 1. So I would say x is less than 1, where x is an element of all real numbers. Now for my range, okay, I'll look on the y-axis this time. The furthest it goes to the bottom is -5. The furthest it goes to the top is +4. So therefore, for all y values, y is greater than or equal to -5 and less than or equal to +4. Okay, and then again, if I wanted to write the interval notation, because it includes -3, I would use a closed bracket. It does not include +1, so I'd use an open bracket. And then for my range, it includes both, so I would use both closed brackets for both. Okay, last example here. So my domain is going to continue on forever to the left and right. I guess I should draw that on the x-axis. It never stops. That arrow does show that it continues forever. So that means my domain would be for all x values, x is an element of all real numbers. Okay, and make sure you're using that proper notation. We are very picky when we mark on notation. So I need to see that curly bracket. I need to see the x in front there with that line. Okay, so all those little details. If I wanted to write the domain in interval notation, I would just use a rounded bracket and say the domain goes from negative infinity to positive infinity. Okay, so for my range, now the furthest it goes to the bottom is -6, and then it keeps going up forever on the y-axis. So for all y values, y is greater than or equal to -6, where y is an element of all real numbers. So then my range, if I wanted to write in interval notation, would be, because it includes -6, I'm going to use a closed bracket. It goes towards positive infinity, I'll use a round bracket. So that's how domain and range works. This is just a review on different functions and examples of what they mean. We'll be using this terminology throughout the lesson or lessons to come. Linear, quadratic, cubic, absolute value, radical. So these should be all reviews from 10C or 20-1. Sum and difference of functions. So now what we're going to do is sum means add, so difference means subtract. So we're just going to add and subtract functions. So we'll start with the first one. So I always have kids who wonder what that x means. It just means for all variables of x. Okay, so you're not timesing this by x. It means for all variables for x. It's function notation. So, for example, if I wrote this instead, it would mean all my variables of x are 3, right? I would substitute 3 in for all my variables of x. All right, so let's go ahead and try adding these two functions. So I'm always going to use proper notation. So I'm going to say f plus g x, or I guess I could just call it h at x. So h at x equals, okay, so you should have the h at x equals. So my f function is fx minus 10. My g function, so I'm adding the two functions, is x minus 3, x plus 2. So what I might actually do is I might go ahead and expand this first before I substitute it in. So you can FOIL this out if you want to, but really it ends up giving you x squared minus 1x minus 6 after you FOIL it all out. Okay, so let's go ahead and add these. So this is my f function, this is my g function. After I add, all I'm going to do is collect like terms. So I have an x squared, 4x minus 1x gives me a positive 3x, negative 10 plus negative 7 gives me a negative 16. So then my h at x function would be x squared plus 3x minus 16. And you can go ahead and try and graph this. Okay, I'm going to just write the domain and range. So the domain for this function, because it's a quadratic, it's just negative infinity to positive infinity. And if you graph, the range for this function would be from negative 18.25 to positive infinity. Okay, because that's the y value of your minimum. Okay, so that's how we add the functions. I'm going to erase this so I have room, and now we will subtract the functions, and I'll show you what that looks like. So when you subtract the functions, you're taking your f at x, and now you're subtracting your g of x. So I always have kids who make this mistake. Make sure when you're subtracting that you don't forget to distribute that negative. So then I'm going to have minus x squared plus 1x plus 6. After I distribute that negative, I will collect like terms, and I end up with negative x squared plus 5x minus 4 as my final answer there. Okay, and then if you graph it, your domain would be negative infinity to positive infinity, because once again, this is a quadratic. But then your range would be negative infinity to positive 2.5. Because we have a negative a value, the graph will open downwards, which means we will have a maximum point there. Okay, so when you're adding or subtracting functions, sometimes you'll be asked to add and subtract the functions given two equations, and then you'll use some algebra. Sometimes you'll be asked to add and subtract the functions using a table of values. So what the table of values means is at this x value, the y value at f at x is negative 3. The g value at negative x is, at negative 2 is negative 5. So all I'm going to do is I'm going to add these two numbers together. So negative 3 plus negative 5 is negative 8. So what this means in terms of my graph is on my graph of f plus g at x, when x is negative 2, y would be negative 8. So this would be my ordered pair of my new graph. So what I'm doing is taking these two graphs and combining them to form a new graph. And then you would just continue on. So for the next one, you'd add negative 1 and negative 4, and you'd end up with negative 5. So your new graph would have an ordered pair of negative 1 and negative 5. Okay, and you can go ahead and keep filling that chart out. Subtracting, same thing. Make sure you pay attention into which order that you're subtracting, because that will change your answer. So I'm taking f minus g. So I'm going negative 3 minus negative 5. Negative 3 minus negative 5 gives me a positive 2, right? Watch out for that double negative. So now my ordered pair of this new graph would be negative 2, 2. And then you would just continue on. So this is the rest of my table of values, okay, when you're checking it. All right, so my next question says, given the function 7 minus x and 2x plus 3, sketch the graph, state the domain and range. Okay, so you're gonna probably do a little bit of algebra here. What I'm gonna do is, because we've already done one where you use algebra, I'll get you to try this on your own. However, I will write the answer down. So you should end up with negative 3x plus 6. Your domain should be negative infinity to positive infinity. Your range should be negative infinity to positive infinity because it's a linear graph. For the next one, your new equation for h at x after you add the function should be x plus 8, and then your domain and range will be the same, negative infinity to positive infinity. Okay, so the domain of the sum or difference of two functions. So actually we're just going to skip ahead to this next one. So now the third way you could be asked to combine functions, to add and subtract them, is by using a graph. So in this case, what you're going to do is you're going to pay attention to the graph. So that's why it's nice that we have the different colors here. So we're adding. So remember, this 4 represents the x value. So instead of adding f plus g at x, we're adding f plus g at 4. Another way you could write this, which sometimes makes sense to kids, this is the same as if I wrote it like this. It's the same thing. So what I'm doing is I'm finding the y value at 4 for my f function. So let's go ahead and do that. So when x is 4, my y value is 5. And then I'm adding the y value of g at 4. So my g function at 4 has a value of 3. So really I'm just taking 5 plus 3 and I end up with 8. Okay, now we can try the next one. So again, you can rewrite this function like this if it makes more sense to you. That negative 5 represents the x value. So if I go where negative 5, okay, at f, my f function, it equals 7. At my g function, my negative 5 equals 0. So I have 7 minus 0 equals 7. Okay, here's another example. This one is just a little bit of thinking outside the box. If at this time they give you f at x, they give you 8, you're trying to find g of x, and they give you h at x. So you know this whole function should equal 3x squared plus 4x minus 2. So really you're just looking, what's missing? Right? What's missing? If I need to add these two functions and this is my answer, what's missing here? So I know that I'm missing a 3x squared. I know that I'm missing, in order for me to get 5x plus what gives me 4x, I'd need a negative 1x. And in order to end up with a -2, I'd have to add a -4. Right? Another way you could do this, if it makes more sense to you, is you could actually just subtract that 5x plus 2 as well, if you do that to get your g of x. Again, if you do that, don't forget to distribute that negative. Okay, so both ways work. Last question, this is a diploma question. It says sketch the new graph. So what I'm going to do is I'm going to actually draw these graphs on the same grid. Okay, so we're taking these two graphs and drawing our new graph. So the first thing is you need two y values in order to add or subtract. So that means right away our domain for this new graph is actually going to be from 0 to 4, because those are the only places in the graph that I actually have two y values to add or subtract. So sometimes your question will be as simple as, what is the domain of the new function? So without even doing anything, we know the domain of the new function is between 0 and 4. All right, so now let's go ahead and add. So we have 2 plus 0 gives me 2. 3 plus 1 gives me 4. All I'm doing is just kind of moving along my x-axis here. 2 plus 4 gives me 6, so this graph is going to go up to 6. 1 plus 4 gives me 5. And 0 plus 4 gives me 4. So this is what my new graph is going to look like. Okay. And here's some questions that you can try when you have time.